So, lesson 27, multiplying polynomials, right on the heels of adding and subtracting, which we will use. By the end of this, you will be able to multiply monomials. Check. Probably a different color would work, huh? Check. And then I will be able to use the distributive property to multiply polynomials. And we're going to go through pretty much all the monomial times monomial, binomial times binomials and trinomials, okay? But we start with just the simple ones, the monomials. And actually, we've done this before with exponent rules, all right? We're just calling them monomials now. Monomials are the simplest because they consist of one term. Like Monopoly, it's only when one person wins. Like when Amazon takes over the whole world, they will be the only one left. So we're going to multiply these because we're finding products. And remember our rules for this. We can use the commutative property because it's all just multiplication to break it up. 5 times 2, x to the third times x to the second. But what we really do is we really multiply the coefficients, the big numbers out in front, and add the exponents. Because if we're already multiplying here, I can't multiply here. I got to do something different. I got to add. So I would end up with 5x's. And that just makes sense. Because if I had 3x's and 2x's, you put them together for 5x's. You never had 6. And then we have negative 3x times negative 8x. Sometimes the simple ones confuse us. Don't forget there's a 1 here for an exponent. So if you want to, you can rewrite this. Don't really have to. And remember that it's 1 and 1, so we add those. So a negative times a negative, positive 24. 1 plus 1 is 2, and voila, you have it. And guess what? When you multiply a monomial and a monomial, you get another monomial. All of these are just one-term finishers. When you get really good at this, you probably can do this without the commutative property. You can probably start to see the negative 4 times the 3 is simply negative 12, and that you're going to add 2 plus 3. You're going to add the exponents for the x, and then for the y, it's not just one y, because I've got a y here and a y there. There's actually 2 y's, so 1 plus 1. So negative 12, x to the fifth, y to the second. And the more we do this, the more that I'll start to show you some shortcuts, because it's better to use your head than to use a process, just to kind of think about what you have to do every time. All right? Well, I hope you're with me here, folks. This is a quick one. Like I said, we're going pretty quick. So let's move right ahead to distributive property, which, again, you've heard this before. Commutative, associative, distributive. Talked about them at the beginning of the year, not so that they would go away, so that we could use them throughout the year. So now we got to pass out something. And what we're going to pass out is the number out in front. So that 2x is going to go into this binomial. And it's not just the 2, it's not just the x, it's both times. So I'm going to write this out the long way. 2x times 3x is what the first piece is going to be. And then let's assume it's positive, so let's go plus 2x again, because I got to send the 2x out to the negative 1 times negative 1. So again, I'm showing you the long way the first time, and this is basically monomial times monomial, right? So we multiply this together, 2 times 3, 6, x times x, x to the second power. And then it's 2x times negative 1. Not a lot's going to change here, but it is a negative times a positive, a negative 2x, and it ends as a binomial. And I want to write this to show you that these can't be subtracted. They are not like terms. Okay? Well, that's the official way to how to do this. I'm not going to keep it that official. We will start to take some shortcuts, especially with the next one. Let's go with a different color, something fun. There we go. So I'm going to take my x squared and I'm going to pass it out twice. I want to make sure that it gets multiplied by both of those terms here in the binomial. Now remember that if it's a x, there's a 1 there. So 1 times 4, that's not going to change, still 4. But if I'm putting 2 x's with another 2 x's, that really makes 4x. 4 x's. So 4x to the fourth. A lot of 4's there. And then we do it again. The x squared goes to the 3. Now there's no x here. There is 1 times 3. For 3, that stays the same. X squared goes along for the ride. And voila, we have 4x to the fourth plus 3x to the second. Same variable, different exponents, so a binomial. Interesting. And finally, we'll finish up. Let's go this one. With this one, which has got a lot of terms in it. So just make sure you're keeping everything in mind when you multiply this times this. So a -2 times a +2. Keeping the numbers very small here, just for simplicity here. -4, right? And then if I have 2 x's with 1 x, I've got 3 x's. And if I've got 3 y's with 1 y, I have 4 y's. So 2 plus 1, 3, 3 plus 1, 4. And then we do it all over again. So it's this right here times the -5x. A negative times a negative, +10. 2 x's with 1 x makes 3. And what do we do with the y? It doesn't have a friend. We bring it along anyways, right? So we bring it along for y to the third. It's got to go because we are distributing it to both terms. We end up with something that, wow, has 3 pieces in the front, 3 pieces in the back. But that doesn't make it a binomial, or it's a trinomial. It keeps it a binomial because there's only 2 pieces split up by 1 plus sign. So a binomial again. Okay? Just going to keep hitting you with that terminology so that you get used to it. And it seems like we just started, but like I said, this was going to be a quick one. Thank you to Caleb and Matt for making it so quick, because if not, we'd probably be still stuck talking about the warm-up. So again, thank you for participating. And I hope to get some of you participating right now, because this is as hard as it gets today. We are going to do a little bit of multiplying and a little bit of adding all together now. So let's look at a few examples when distribution may not be the only operation. Now this comes down to what do we do first, and I kind of previewed this for you last class. If I see this, okay, which is multiplication comes before subtraction and addition. Yes, it goes back to the order of operations. So I pass this out. So I multiply by -5. So that's -20. -5 times 4. X to the second power, that stays the same. Then it's -5 times the -7. I got to multiply both things by a negative. So important that we do that. +35. Now, let's drop down the 4x. Let's bring down the 21 because that was not affected by distribution. I got to find like terms here, but I got to also write it in standard form. Remember that standard form puts the largest exponent first. So this is going to be -20x squared. Why? Has the largest exponent, nothing else like it. Next largest exponent is simply the 1, x to the first power, which also has no other things like it. So that goes down as 4x to the first. We clearly have some like terms here, so include their sign in front. A +35 with a +21. A little bit bigger numbers here, but we got this. +56. So there you go. It has 1, 2, 3 non-like pieces for a trinomial. Bam. And with one left to go, here we are with another example where, what do we do first? Do I add? No. Do I subtract? No. Do I do what's in parentheses first? No, because you can't, right? Even though it has parentheses, you can't add unlike terms here. So what do I have to do? I have to distribute this -1. Doesn't seem like a lot, but guess what's going to happen? It's going to make this -9x to the second power and -4. So it distributes and makes both of those terms a negative. Let's go ahead and bring down the other pieces of this puzzle, 8x plus 7x squared. And I'm going to stop right there. I'm going to give. When we're looking at this, we got to identify the like terms. So the like terms are the ones with the same variable, same exponent. Now, integer rules apply here. You have $7, you owe somebody 9. If you give them that $7, you still owe $2, and we don't change this because we're adding, okay? This and this, we're being added together, so do not add the exponent here. Super important. 8x here with a -4? No. So this is something different. Maybe a straight line for this. 8x. And then finally, this is a -4 with no other term. So there you have it. What type of polynomial do we end with? Put it into the poll question, and we'll be done for the day. Or put it in the chat, that is.